Hey everyone, this is Miss Moriarty and I'm here to discuss with us our topic 7.5, which is all about indoor air pollutants. Now, what many people forget is the fact that we spend a lot of our time indoors, and while indoors, we are still continued to exposed to different types of air pollutants, and so sometimes we can even consider indoor air pollution a more greater risk than even some outdoor air pollutants that we've now spoken about. Now, what may be some sources of indoor air pollutants? They can come from natural sources, like plants that we have in our home. They can come from man-made things like the furniture and carpeting that we have, as well as maybe burning wood or even cigarettes. Now, looking at developing nations and the impact of their indoor air pollutants, for them, remember thinking back to Unit 6, those types of countries tend to use more subsistence type fuels, ones in which they can easily obtain and is fairly cheap for them. So that's things like wood, manure, or charcoal, right? Anything that would really fall under the classification of biomass. But when we combust and burn biomass, it is going to release things like carbon monoxide, particulates, nitrogen oxides, and volatile organic compounds. When these are combusted indoors with poor ventilation, this can then lead to high concentrations of really any of those types of pollutants. Worldwide, approximately about 4 million deaths are contributed to indoor air pollution each and every year, and majority of those actually wind up being children. Now, what about in developed nations, right? We're obviously not using really biomass to heat our homes. We are using more commercial type fuels like coal, oil, or natural gas. But when typically burned in a very closed and well ventilated area, we may not experience those same types of sources of indoor air pollutants, but we are still exposed to them on a daily basis. So usually for developed nations, we tend to be exposed to pollutants that come from a lot of like chemicals found in the products that we find in our homes. So things like paints or cleaning fluids. Here it mentions tobacco smoke, carpeting, insulation, old paint, maybe the rocks and soils found within the foundation or beneath the home. All can expose us to different types of pollutants on a daily basis. So mainly focusing on particulate matter and asbestos first. So we know back from 7.4, particulates are very small particles that can take different sizes. They can be less than 2.5 micrometers, less than 10 micrometers, and depending upon the size, usually translate to how deep in the lung tissue they can go. Some sources of indoor air pollutants where we see particulates is going to come from smoke, right, or the burning of biomass indoors, cigarettes, even dust can also be considered a particulate. Now, what about asbestos? Asbestos is a long, thin, and fibrous silicate material that was once used for insulation. We don't really see it being used anymore. It is a carcinogen when inhaled. It's really been kind of phased out at this point since we know it can be highly dangerous. But it really only wound up being dangerous when we disturbed it. If you do find that you have asbestos in your home, which a lot of homes still do, especially if they are on the older side, you need to hire a team of trained professionals to go in with the proper respiratory equipment, ventilate the area, and remove the asbestos from the home. Now, what about carbon monoxide? This is kind of a little bit more common than asbestos. We could see carbon monoxide come from the incomplete combustion of really any type of fuel. Now, why is carbon monoxide so bad for human health? Carbon monoxide is considered an asphyxiant, meaning that it's going to cause suffocation. How does it wind up doing that? Well, when you inhale large amounts of carbon monoxide, when it flows within our bloodstream, it's going to bind to the protein known as hemoglobin, which is found in our red blood cells. When it binds to the protein hemoglobin, it actually displaces oxygen that would normally be carried around our systems, hence creating suffocation. So in high doses, it is very lethal to humans, especially in areas that have poor ventilation. It is dangerous because it is odorless and colorless and incredibly hard to detect. Now, developed nations, we usually see a carbon monoxide poisoning or an accumulation of carbon monoxide in the home when we see a malfunctioning of your furnace, versus in developing nations, that can simply come from burning indoor biomass. So that could be used for like heating or cooking. But in order to combat carbon monoxide, every home is required to have a carbon monoxide detector. Now, how about volatile organic compounds? We know VOCs help to contribute to photochemical smog, but how do they contribute to then indoor air pollution? Well, we know VOCs can fall under many different sources of categories. They can vaporize into the air, irritate our eyes, and infect our lungs and bronchioles. Where do they come from in indoor air pollutants? They can come from adhesives and sealants, usually used to hold carpet down, hold furniture together. Formaldehyde, which is a common adhesive, can also emit volatile organic compounds. Common household cleaners like Febreze, deodorizers can all emit VOCs. Even some plastics and fabrics can all emit volatile organic compounds in some manner. And then what about radon gas? Radon gas is a radioactive gas that's going to be released from the decay of uranium, which is naturally found in rocks underground. Now, depending upon where you may reside, especially in the United States, you can see by this diagram here, in some areas you might have a higher chance of having exposure to radon versus in some other areas. Kind of really just depends on the type of bedrock and soil that remains in that specific location. Now, how does radon wind up in your home? Radon can naturally enter the home through any cracks within the foundation of the home. It can seep also into your groundwater resource. It is odorless. It is colorless. It is the second leading cause of lung cancer after smoking in the United States. And so it does pose a tremendous threat to a lot of people, especially since we spend a lot of time indoors or even at home. Now, what the EPA recommends is to test your home with a radon testing kit, especially if you are in an area that has that type of bedrock. And if you do find that you have high concentrations of radon in your basement, they do recommend to try and go in and seal any of those cracks in the foundation, increase any ventilation in your home by, opening more windows, and so on. Now, what about dust and mold? They can also be considered indoor air pollutants. They can worsen things like asthma, bronchitis. We know that in homes, dust can settle on different objects, especially if it's not disturbed for long periods of time. That can enter into your airways and irritate your airways. Mold can develop, especially in areas that are very dark and damp, right? Things like under the sink, the shower, behind any walls. Things like black mold have the potential to then release spores into the air, which can also be respiratory irritants, and usually need to be removed physically by cleaning the mold and fixing whatever leak or ventilation issue you may have in your home. And then lastly, lead is going to fall under this category as well. So in the indoor air pollutant category here, lead is not necessarily being emitted in the air. It's actually more found within our water supply. So we've talked about this before, but we can see actually lead can be found in very old homes, since they actually used to use lead in paints back in the 70s or so. We know that that is now phased out, but if you live in a home that is very old and may not have been renovated, those paint chips can come off the walls, can come off the windows. Usually small children who are very curious, put things in their mouths, have actually been found to consume a lot of that lead and get lead poisoning as a result. Some other ways you might be exposed to lead could be through the lead found in your water pipes. This was actually one of the Part of the reasons why in Flint, Michigan, a lot of the children as well as the adults wound up getting lead poisoning because the pipes were incredibly old, corroded, and as a result, the lead wound up in their drinking water supply. When you are exposed to high accumulations of lead, it can have the potential to damage your central nervous system. It can be removed from your home by stripping any lead paint that may be on the wall and replacing any pipes that are originally lead-based to a non-lead-based type of pipe, like copper. All right, folks, here is our practice FRQ for 7.5. Take a moment and please pause the video and answer in your note packet and on the Edpuzzle. All right, at this point in time, you should have answered the FRQ. Here, the FRQ states that the EPA of the United States recommends taking any corrective measures to reduce your exposure to radon gas. They've set this action level as being 4 picocuries per liter for radon gas, which is a very, very small amount. The graph below shows radon samples taken from 17 different buildings in California. The radon samples were taken from the air inside of those buildings and the uranium concentrations sampled from their soil. And the data points from the 4 of the 17 buildings are located in the graph. So you had to identify which data point posed the greatest risk to its community, as well as B, how could they wind up reducing their risk of exposure. So the answer for this would be area A. A part of the reason why it was area A is because we saw the greatest radon concentration in that area versus all of the other points identified. And how could they wind up reducing their risk? Well, they could probably increase ventilation in the building, open more windows. They could also go in and most likely seal the cracks of the foundation of the building to hopefully reduce their exposure to radon in the future. All right, everyone, that's it for our video. Please make sure that you leave a question at the end.